This is the guts of a Ryobi RYi1802B6 40 volt inverter power station thing. Overall, fairly typical of what I'd expect in this thing. Two main circuit boards inside the main clamshell. This board on the left here is battery management, so there's a pair of FETs for each battery that are used for charging control. Since this thing works by what's basically round-robin charging, so it's got one common 42 volt input from the external charger brick. It's the same charger brick that they use with their smaller 42 volt chargers, where there's a separate thingamajig that clips on top of the battery, and then it goes to one of the just a standard black plastic brick charger, and it charges each battery in sequence, which takes a while, but fully kitted out, this thing's got about 800 odd watt hours of capacity, and that charger charges at a maximum of 63 watts, because I think it's up to 42 volts at a current limit of 1.5 amperes. Then it also has battery current monitoring, so there's a 1 milliohm current sensing shunt. Those are those shiny rectangular things right there. So it's monitoring the current in each battery to detect if there's a problem. Various, what I'm guessing, are very hard to read because this board's conformal coated, but those are probably just operational amplifiers and stuff. FET drivers, etc. And there's also a pair of FETs over here, as well as a diode that is for the supply to the inverter. And the diode is reverse biased, so it's probably just serving as a transorb. So that way any transients from the inverter can't get back and grunk the batteries, because lithium ion are kind of sensitive to things like that. Then there's a Freescale microcontroller there that's doing all the charge management and stuff. It's power supplies. That's what those inductors there are for. And then over here there's a couple of 40 volt. Well, technically it's 37 volt nominal, but 40 volts because market rates. There's this, which is the 40 volt supply that goes off to the USB charging board. And there's this, which is the 40 volts in from the front panel charging jack. And there's a breakout board which just combines various signals coming from the battery charging board and the inverter board going off on this one common cable, but then there's also various other stuff which goes to this directly. Then up here there is the inverter. So right here there's this, which is the 120 volts that goes out to the front panel receptacles. These inductors here, along with the capacitor that you can't see because it's under that blobous elastic goo, that is the output filter. There's this, which there's only two devices on it. So wait a minute. I don't know, there's four. So that is either the output H bridge or rectification. And then there's this, which also has four devices on it. So that is, again, these two. One of these is the output H bridge. One of these is rectification of the electricity coming from the main transformers, which is interesting that there's two of them. And then there's a bunch of what I'm guessing are DC link capacitors there under that elastic. There's three standard, dark red epoxy dipped film caps there. Then over there's a auxiliary power supply, which is that transformer and its transistor, and then the actual control ICs are probably on the other side of the circuit board. Well, actually, they would be on the other side of the circuit board. And over there, those screw connections, that is the 35 to 42 volts coming from the battery board, a ripple suppression capacitor there, but the main ripple suppression for the output is right there. Focus you. There we go. And then a cooling fan, which, this thing does need, especially at higher power levels. And so yeah, it'd be interesting to see exactly what they're doing with the two different transformers, because they are distinctly different. See, this one has a bunch of big Litz wire windings there. So, anyways, that will be a subject for a much more detailed teardown. which, you know, I don't want to do because, again, this thing cost me, you know, $700 and I don't want to destroy it. It's not without good cause. And of course, fairly interesting is that they've got circuit board mounted thermistors for monitoring the temperature of those heat sinks, instead of the normal thing where you'd see basically a screw-on thermistor directly. So anyway, somewhat interesting construction detail. Then those circuit boards there are for the battery charging status idiot lights. There's two more on this other side of the clamshell right over there. And then those are the battery connections right there. So it's got, yeah, those are the wires for the idiot lights. Those are for thermistor monitoring, and the actual 40 volt from the battery going to the board. Then on the main, or on the control PCB right here, there's this thing under this can, which is all the various DC to DCs for the USB charging ports, because it's got 5 volt only USB-A and 5 volt, 12 volt, 20 volt USB-C, which, judging by the tracks on the board, are isolated, so you can charge two different things at two different potentials off of the USB-C, which is useful. Bunch of ripple suppression caps there and some filtering. That's the 40 volts in to supply the board. Receptacles for the 120 volt output, as well as its thermal breaker. The paralleling banana jacks, which interestingly they cross, so the regular receptacles neutral's on the left. With these, it's on the right, and likewise with the receptacles, hot's on the right, and it's on the left with the banana jack. So that's, I don't know, somewhat interesting. And then under it is the main control PCB for the user interface, and it's got all the switches and stuff on it, as well as the screen. And then this is the input charging jack. Also, interestingly, that this has yellow Celastic, whereas it's white on the other one. So this is probably a bought-in assembly from a different factory, or at least a different part of the plant, or given what a complete mess supply chains are now, they had one color Celastic when they were making these, because that is interesting. 53 to 2020. That's backwards from the normal EIA standard. Normally the date code is year, year, week, week. This is week, week, year, year. So, yeah. Anyway, just overall looks fairly skookum for what it is. I mean, yeah, it is quite expensive for a 1.6-ish kilowatt inverter, and judging by the size of the transformers, I really wouldn't push this thing over like 800 to 1000 watts on a regular basis. But I mean, I've ran a welder off of this thing multiple times in multiple videos, and it sometimes runs it happily. And as a load test last night, I actually ran a 1.5 kilowatt kettle off of this, and it did run it, but it did get not screamingly hot, but up here it did get noticeably warm. And all the cooling fans kicked on, because this thing does have 3 cooling fans. There's the one in the main back grill, which would be here. Then it's got this one for the battery charging board, and this one for all the various heat sinks in the inverter. So yeah, but overall, yeah, it is what it is.